Here we go. We're on section 4.5. These are the notes. I asked you in class today to plug in 0, 1, 4, and 9 for x. And what do you get for y? The square root of 0, square root of 1, square root of 4, square root of 9. Plot those points. 0, 0 is right there. 1, comma 1. 2, 3, 4, comma 2. And 9, comma 3. And what you have is half a parabola laying on its side. I say half a parabola only because we do not also plot 1 or negative 1, 2 or negative 2, 3 or negative 3. And the reason is, if we did, it wouldn't pass the vertical line test, and it wouldn't be a function. So the square root symbol is defined as the positive root only. Positive root only. All right? So what we find is that the domain are any x's that are greater than or equal to 0. We can continue with larger numbers. What we can't do is plug a negative in, like negative 36. That's the one at the bottom there that gave you a non-real answer. True? So we would say either, I don't want to say it's undefined because it is defined. It's just non-real. More about what non-real means later in this school year. All right? But for now, just know that the domain, meaning the numbers that are allowed to go into this function, have to be greater than or equal to 0. And the range is the numbers that come out of this function for y, and they have to be greater than or equal to 0 as well. Down here, you should have gotten 2, 2.8-ish, and 5.6-ish. All right? And then for the square root of negative 36, you get a non-real. We'll talk about other ways to simplify the square root of 8 later this week. Instead of getting 2.8, you can actually simplify it and do what's called just simplifying that radical. We'll talk about that later. Next, you are to enter these into your calculator, so go ahead and do that if you're watching the video at home. Enter these into your calculator, and then sketch the graphs on the grid here in 4 different colors. Go. Press pause and do that. Now that you're back, you should find that negative square root of x looks like this. Square root of negative x looks like this. And there's one more that produces this guy. That was the one with the double negative. Negative square root of negative x. So what we're finding is playing around with where this negative goes has an effect on the reflection of the graph. A negative outside the parent function reflects the blue graph downward. A negative inside the parent function reflects it horizontally that way. And a negative outside and inside the parent function reflects it both ways, down and then over. If you need to rewatch that part, go for it. Moving on. By the way, we're going to come back to this several times as we move through this section, this concept of where does it go depending on where the negative is. So study that, think about where that negative sign is and what it does to the graph. Y isn't an entire parabola. I already said that in this video. It would not be a function. It wouldn't be a function if you were allowed to graph the whole thing like that. Wouldn't pass the vertical line test. What functions could you graph at the same time to make it a parabola laying on its side? So what would we put in for y1 to produce the top half? The square root of x. What could you then put into y2 to produce the bottom half? The negative square root of x. You have to put it in as 2 separate functions in y1 and y2 to get it to graph the full image. All right? Next, reflecting other types of functions, you can do this on your own. Take a look at y equals x and y equals negative x. What do you notice? Complete that on your own after you graph them on your calculator. Enter y equals x squared and negative x squared and see what happens there. And answer these questions for Wednesday. Finally, what we have here is the definition of what's called a reflection. And down so I can reach it. We have a reflection being a transformation that flips a graph across a line, creating a mirror image. Given the graph of f of x, f of negative x is a reflection across the y-axis. When you made inside the parent function negative, it flipped it over the y-axis. Remember, we had this. Square root of negative x flipped it that way, right? And we graphed this image. On the other hand, you have a reflection where the negative is on the outside like that. That's going to be a reflection over the x-axis. That concludes your notes for 4-5. Come to class next time we meet, ready to do an investigation, and we'll complete the homework in class that day.